originally had the idea for designing an autonomous vehicle when I was taking apart one of my old RC cars. It could only drive 10 miles an hour and couldn't even be controlled autonomously. While creating an initial design, I had originally conceptualized the car to be small, to be a slowly crawling vehicle and used as a UGV, unmanned ground vehicle, for my UAV team. At the same time as I was planning all this, Tesla unveiled the Cybertruck, which at the time had a super stunning design. My team joked that putting a Cybertruck frame on our little UGV for the competition in the spring would be super fun, but little did we know that there would be no competition in the spring due to coronavirus. However, this gave me tons of time to start prototyping the vehicle, and it all gradually formed into the project that it is now, a fully autonomous mini Cybertruck that can also be controlled by remote control. The first thing I worked on was finding all the necessary parts for my vehicle. Although, reluctantly, I robbed my old RC car for all the parts. I stole 2 back wheels and an axle, 2 gears, as well as a steering mechanism from the front. Additionally, I just purchased a 3D printer earlier that spring, so I knew a majority of my parts were going to be 3D printed out of PLA. However, I wanted a stronger material than PLA supporting the vehicle chassis. To accomplish this, I used 2 metal rods at the backbone of the vehicle. The steering mechanism in the front, as well as the gearbox in the end, would slide onto the rails. Additionally, the electronics and battery mounts and GPS would all slide onto the middle section. Using the 2 bit of rails also provided the vehicle with a little bit of torsion in stabilizing it as it went over bumps. Additionally, this platform would serve to remove the Cybertruck frame from the chassis. I did this with 2 clips and 2 guide rails the frame would slip onto to be mounted. This would keep the frame on during rapid accelerations, which it is definitely capable of. After designing these parts, I finalized 5 chassis parts to be printed: the steering mechanism, the Pixhawk mount, the GPS mount, the battery mount, and the gearbox. Breaking the structure into these parts helps break up the print times, as well as cause less damage if a print failed. Designing the gearbox was one of the most challenging parts of this project. Not only did it have to keep up with the intense heat and friction of the gears spinning, but it also had to last for a long time like this. My entire need for a gearbox came down to using a motor that was way too powerful. I originally intended the vehicle to only be able to travel at a max speed of around 5 miles an hour, but I soon became aware that even gearing the motor down as far as I could, even a 16:1 ratio, it would still travel upwards of 6 times this, up to 30 miles an hour. The main issues I had with the gearbox was the intermediate gear in between the motor shaft and the axle. In initial designs, this was fully mounted in plastic, or PLA, but as 2 failed field tests showed, the plastic kept getting melted around the mounting point. Later, I replaced this with metal nuts, which seemed to fix the issue. Additionally, I added lots of grease to reduce the friction and the sound caused by the gearbox. All 3 gears were stolen from the old RC car, which was beneficial since they were molded to shape, not 3D printed. This meant they didn't break as easily as 3D printed ones could have. To connect the gearbox onto the rest of the chassis, the gearbox slides onto the end of the metal rods and is secured with hot glue. Overall, I am very proud of how this gearbox turned out and might even use it on future projects. As for the electronics, they're not super complicated. However, using a motor did make them a little bit more difficult. Here's a basic summary of what's going on. The Pixhawk is the flight computer on board the vehicle, which controls the outputs: 1 servo motor to steer, and 1 brushless motor to drive using PWM. However, since a brushless motor can't understand a pulse width modulation signal by itself, we use an ESC, electronic speed controller, to control the actual speed of the motor. To power all these onboard electronics, we need a battery. I use a 2-cell LiPo, which supplies 7.4 volts. Finally, for the vehicle to drive by itself, it needs to know where it is. To do this, we have a GPS, and to communicate back to the ground station, we have a telemetry radio. Normally, a person monitors the ground station, like a computer, and communicates with the car over a telemetry radio. To control it over RC, remote control, I also have a receiver underneath the picksock mount at the bottom of the vehicle. Other than that, I added a safety switch to arm the vehicle and a buzzer so I know when the voltage of the battery is too low. All of these devices have a plethora of wires between them and are secured using zip ties. The single source of control that I had on the steering mechanism was the use of a positional, not rotational servo motor. This was much different than the old steering mechanism, which used a brushed DC motor. However, there were some advantages. The old motor had to be geared down, while mine doesn't. I went through 4 prototypes before settling on my design, each of which progressively got better and more complicated. Basically, this steering mount had 4 objectives. 1. Mount the servo to the steering mechanism. 2. Mount the wheels, allowing them to spin without interruption. 3. Slide onto the metal rods in the front of the truck. And 4. Allow the casing to be slid into these 2 mounts in the top. I printed a custom servo head adapter to slide onto the old steering mechanism, and also screwed in the servo so it wouldn't move around while the car is turning. Although one of my concerns is that the small 9-gram servo wouldn't be powerful enough to turn the car, it's proven that it is. I'm very proud of this steering design. In the end, it allows the car to turn pretty sharply, but more importantly, it can drift. Although this is technically the 3rd version of the UGV Cybertruck, I still have many ideas for how to improve it. Primarily, I would widen the distance between the metal rods. This would not only keep the vehicle more stable, but it would allow me more room for wiring and mounting the electronics. Just increasing the width by a little bit could allow me to mount the battery sideways, improving the clearance of the vehicle. Also, this would add more space for removing the battery, which does prove tricky at times. More importantly, however, I would try to use more standard parts, like a standard threaded rod and bolts. For this project, I just used old bolts that I found in my garage. To better manufacture the Cybertruck frame, I would use a filler spray instead of Bondo. The Bondo worked well for large areas, but for example on the front, there are a few areas that got covered a little bit too much, and it made the front look bad. Finally, I would redesign the gearbox to use metal gears, so that it could last longer. One of my main issues with the gearbox was that the plastic mounts kept melting under the extreme heat that the gears spinning provided them. Although with a metal gearbox, the weight would increase, it's still a benefit to the vehicle. So yeah, that's it, the autonomous Cybertruck. If you have any questions, leave them in the comments and I'll respond. Please subscribe so you can see more cool stuff just like this. Thanks.